Hello and welcome also from the product management side to today's What's New session in SAP Datasphere. This is the October session, so we're covering features and functions we've added in the last quarter, so Q3 from July till September this year. And looking at the agenda, we cover updates in all different areas of the product. And without further ado, let's directly jump into some general updates we want to share with you. And first and foremost, there are guidance documents which have been updated in the recent months. So we updated in August the statement of direction document covering the BW, BW4 HANA, as well as Datasphere products. We also updated end of July the BW Bridge Remote Conversion Runbook, also a great help that was not only updated but also extended in various areas. And in September, we also updated our first guidance document with development guidelines and naming conventions, which you find, like most other topics, on our best practice and troubleshooting page. With that, I'm done for the moment, and I would like to hand it over to Stefan to give us more updates.
Looking at general product updates, we have first new data center deployments. SAP Datasphere is now available in Azure as well as Google Cloud Platform. In Azure, we have released EU20 Amsterdam and US20 US West in CPA and subscription, and each also with a possible extension of BW Bridge already available today. On Google Cloud Platform, we have now released US30 to customers, but only in subscription for now. And BW Bridge is also not yet available because it's only coming in early 2024. So now customers have more options to deploy their SAP Datasphere tenants. For more information about what services are available for what tenant or data center deployment, please find the link listed on the slide here. Another cool product feature that might appear as a minor one, but it's a very useful one, I think, and customers have requested it a lot, is specific page or tab titles. So when navigating through SAP Datasphere, for example, from the landing page of the data marketplace to the search of the data marketplace, the page titles in a browser also reflect on what page in SAP Datasphere you're currently in. For example, you can see the data marketplace landing page is reflected in the tab title. And the cool thing here is when working with multiple tabs open in SAP Datasphere, it's now easier to navigate. It's easier to have an overview of all the tabs open. And also when taking bookmarks, you don't have to rename tabs to the bookmarks to know what each bookmark stands for, but when taking bookmarks now, it directly states, okay, it's the SQL view builder, for example, which is a useful feature. Yeah.
Thank you, Stefan. And then we move on to the next topic with data integration, data management. Johannes, over to you.
The mass operations user story in the data integration monitor now allows us to execute operations for multiple items in the data integration monitors. One of the most prominent ones is, for example, to pause and unpause a schedule. Not all operations will be possible. Operations like creating a schedule do not make a lot of sense, as they would all be created at the exact same point of time, and therefore those we have removed. Same as creating snapshots, which again would execute everything at the same time, and if you do so for a large set of entities, would probably overwhelm a system. How is this implemented? It is actually fairly simple. We now have the ability to select objects or to select all objects in a given monitor, and then basically use the buttons on top of the table, like here, to pause schedule, to pause all schedules which I just had been here. So we are seeing actually how much schedules have been paused, because operations will only be executed for entities where it makes sense. That means if you over-select and things do not have a schedule, and they will obviously not be applied to those objects. This is there just to simplify a little bit the work in the data integration monitors. The local table partitioning user story now allows us to partition local tables. Previously, we only had the ability to partition views and view persistencies, as well as remote tables. Now, this feature is also available for local tables to either allow to store larger data sets or help with the data loading performance. And it basically orientates itself on the scope that we had with the remote tables. The only major difference we will see in a remote table, it is a runtime entity, as the design time comes from the source. And in local tables, it's a design time entity. That means it is applied when deployed. And it can only be applied if there is no data in the table. So this feature currently does not support any active repartitioning of data. How is that done? I have a local table open here, and I've created already some columns in the data, and as I said, it's empty because I can still create partitions. We now have a partition section. We can go into define partition, and if I do so, I can no longer add keys because I'm currently using it without keys. If I'm using it without keys, you can see I have access to all of the columns. Not all columns will be allowed to partition. Blob fields, for example, are not able to be used for partitioning. Now see all, if I have keys, so if I activate keys on some of those columns, I can also only select those keys. So you see, as soon as I have keys, only key fields will be shown. And if I have a partition, I can define the ranges similar to what I have in the remote tables. It needs to be again closed intervals, and we will also create the rest partition. All of that is used to, but with that I have created my partitions and then have my partition sections down here in the table, and this will become active as soon as I deploy the table. And with that, I have created a partitioned local table. This will make especially sense with the combination of replication flows, because then it can be used as a target for replication flows. The explain ratings of partitioning columns advisors is a small story that helps understand why the system has rated certain columns for partitioning as good or bad. Before we just shown which ones were good, but now we actually are showing a little bit more about why it is, and if we have multiple ones, what are the different decisions or the different criterias that have led to this final rating. It is just to help the user and understanding a little bit more of why and how we are advising, and it's just knowledge to provide to the end user. No big deal. It doesn't change the functionality, it just displays us how, so that it's easier to understand and make the choice at the end which column I want potentially to use for partitioning. Where can I find this? In the data integration monitor. Once you are in a view and there are no partitions yet, you can choose the define partition button, and the switching on of the rating will basically lead to the same example as we have seen before here. In this case, I get a good rating because this is a primary key columns. All the others are just intermediate, nothing really specific about those. And we have bad ratings because those are numerical or measure fields. In general, these goes through the rules. So for example, if we are detecting certain dates, like even though date in itself should be a good criteria for partitioning, like the last change date, as it's using a heuristic and detecting that's the changeable date, which might not make sense to use for partitioning. And so you have similar heuristics here, like non-changing dates or certain ABAP types, or whether the column date meets a certain heuristic that we are using to evaluate those. And it's just for information. You can completely ignore it if you choose to. Other than that, it just should help you if you don't know which ones are good, which ones to use.
In today's data management and integration section, we have two features: local table data enable and transformation flow, and together with replication flow. I'd like to present this as one section instead of showing individual features and what they can do. The idea is to show this together as one big new modeling concept that we have just released in Wave 20. The idea is that until today we had an ETL flow with the data flows. That means the data flow in its DI pod basically connected to the source. You could transform the data before it was loaded into Datasphere. That resulted in that you had the ability to clean up data in your transformation flow before writing it into Datasphere. That means you got cleaner data or even less data if you aggregated it beforehand. So you might have compressed the information or combined the information. That is what you had before. With the replication flow and transformation flow, and with that also the Delta capabilities, we also introduce now a new approach to bringing this, and this is the ELT, so the extract, load, and transform approach, where the extract and load section will be done by the replication flow, and after the data is replicated into Datasphere, you can transform it. So it is shifting the transformation to after the loading. And compared to being able to clean up beforehand, now you basically bring the data as is, one-to-one, with all its problems and downsides you have. So it's potentially slightly more dirty data, but you have it as it is in the source. And this means you're gaining flexibility. You're bringing in more data, potentially you're bringing in dirtier data, but if the transformation changes, you have now the flexibility to transform without having to re-extract. In ETL, with the data flows, if your transformation logic changes, that always, or a lot of times, meant that you had to go back and extract again in order to load this. This is a conceptual change from ETL to ELT, which we will allow with a combination of replication flow and transformation flows. And combining this extract, load, and transform now with the Delta staging tables, which we see here now in the middle, we're actually gaining a lot more capabilities when it comes to Delta processing and, for example, creating historic truth information by deriving certain parameters or key figures which belong to dimensions of a table. But let's go step by step. So the combination of replication flow and transformation flow is intended to that we use the replication flow to bring the source data one-to-one into a staging table, and this can be done in a Delta fashion. That means I only pull in newly changed data and deleted data. That is something we did not have before. So here now we can also bring deleted information. It is stored in the Delta enable local table with the information about what was changed. Was it an update, was it an insert, or was it a delete, and when it was. So we have an opcode and the local table here, And that information can then be used, including the delta handling, the watermark management, as we call it, the delta pointing, to be read from a transformation flow. That means obviously at the initial load, we will read everything that has been or is there until now. But from there on, the replication flow will bring only new and changed data into the staging table, and the transformation flow will also only process new and changed data in the subsequent in order to write them into a target table. And this obviously means, since the source of the transformation flow is a local table and the target of a transformation flow is a local table, we can do this on a multi-stage level. That means we can have a replication flow bringing the data in, use a transformation flow to stage it in a separate table, and then use another transformation maybe to bring in another one. So the transformation flow is a little bit what the transformation in BW was between two DSOs. And this gives us some capabilities which we did not have necessarily before. So one example which I will also use for the demo is I have sales order items, so line items of sales orders which refer to a product and the quantity, how often the product has been sold and what was the price paid for the product. But if the list price is stored in the product master data, I'm losing that information eventually over time, as the prices might change and evolve over time in my source system. So if I always work with a view where I join the product master data into my sales order items, I only get the current list price because I do not have the historic informations. But if I use a transformation flow and I derive every time the price into my sales order items out of the product master data, I can basically create an historic version of that price in my sales order items. And this is to create historic truth information. An alternative is I could also build a transformation flow from the product master data, and every time there is a change, I can create, for example, time-dependent information, so that I basically just use the current date as the date 2 information to basically create me a historic versions of my product. And if we're looking at this concept, the value propositions of the replication flow is obviously it's there to load large quantities or large number of objects of data with delta capabilities out of the source system without many transformations. And the transformation flow is to streamline the transformation capabilities in one tooling and to execute today SQL-based transformation directly on the local tables. And this will also be one of the core differences between the data flow and the transformation flow. The transformation flow will be executed inside of the HANA application, has therefore direct access to the data. So we do not need to bring the data out of HANA and transform it outside and then write it back into HANA. This will happen inside of HANA. And it has with that also access to full of the resource set. That means you can leverage the entire HANA. To do so, you're no longer limited to these 5 gigabytes that we had in data flows. To give you an outlook, today you can only do SQL transformations, which are based on the graphical view builder. We will release the SQL and the SQL script view building capabilities. So for now, we will have SQL-based logic, but in the future, we will add additional logic coming out of the activation from BW. That means allowing to aggregate, doing change tracking, so getting before and after images. And we're also looking into income, so the reference point calculation, that these types of features go into the transformation flows. And with that is also one important difference, right? Your SQL transformations in the transformation flow have to be capable to work with only a subset of the data. You are no longer pushing the entirety of the data through your view or through your SQL. You're only pushing what has changed, and therefore you need to be careful, especially when it comes to aggregation. If you aggregate, you only aggregate what you have in your Delta package, basically. This will become easier once we have the aggregation functionality in the activation, and this will basically, instead of overriding a key combination, it will aggregate it up into that target table. So that it will use, for example, if we have a summation aggregation and I have for a key combination a value of 1,000 already in, and my Delta package contains another 100, it will add this up. This is not there yet, but this is to come. So let's have a look how that looks in the system. So I'm here in a space that has already connections created. As first, I will create a replication flow and select, for example, here my HANA Cloud connection, and I have to pick my bike sales schema that I want to load from, and I want to load exactly what I used for description, the sales order items and the products. So let me get products and sales order items and maybe sales orders. When I bring them into a replication flow, I have with the Delta tables now the ability, so I choose as target, I'm going to choose my Datasphere itself, so it writes into my space, but I can now turn on Delta Capture. And this will, and we can actually check this here once, we see here we have the columns up till delivery status, and if I turn on Delta Capture, I will get 2 additional, and you see they are marked especially, 2 additional fields. The change type, which is our opcode, basically telling whether it's inserted, deleted, or updated, and the date it was changed, so the timestamp. And we'll use this timestamp to identify which records have been processed by a target and which records have not been processed by a target. So by turning this on, and they become basically Delta loaded, I will activate this replication flow now. And once it is deployed, okay, so it is deployed now, so I can start running it. So let's, while this one runs and starts to replicate, let's look at what the data builder has created or has been created in the data builder. We're seeing now the replication flow as well as the tables. If we look into one of those tables, let's open this up. We see here now there's a switch for Delta Capture. You can also manually set this switch when you create a local table manually. And what we have besides our business name and our technical name, you also have the ability to set a Delta Capture table name. This is because we are creating for a Delta Capture table you basically 2 perspectives on that. The one that will be the products that will carry the active data. So we will filter out the CDC columns as well as we will filter out all deletions, because deletions are not to be. That is the object that is intended to be used if you want to use this table in views. And we have the underscore delta, and you have really to choose a different name, but here the replication flow has created it with underscore delta. That is the perspective onto that table that contains deletion as well as the CDC column. So if you need this additional information, and this is what we will use in the transformation flows to process the data onwards, It has a slightly different name, so you can identify it and you can refer to it if needed to. And we're seeing in our data we have these 2 extra fields now which have been added. And also if we're looking into the table editor, we see that these informations are there. And let me filter out the columns, or a few columns, so that we don't see everything but just see a little bit, and it becomes a little bit easier for us. Okay, now here we see the product ID and maybe just the type code, and we see all L, and L stands for our loaded, basically, so it's initially loaded data. If I would go in and change the opcode now for one product and save it, you see that the change type is moving from L to U, because now it is updated and it has gotten a new timestamp. So the delta tracking not only works when the replication flow writes into it, it also works when you using the table editor. It will also work if you would load a CSV file into with the CSV upload functionality of the local table. Then it will also write you the correct change types. So it will basically track the changes, and you can then continue to load this. If I would do an add, I would create me a new insert record, and that would have the change type of I for insert, just to distinguish between something that has been initially loaded and something that has been manually inserted into those tables. And now we can use this table to create a transformation flow. The transformation flow is a 2-step UI. First, we have the outer transformation flow, which carries transformation operators and the target you write in today. This is because we are only allowing one transformation operators. Here it is intended in the future to allow multiple cascaded transformation operators. For example, you can do an SQL transformation and then add an activation logic, so that you can then later on build chains of transformation which we chain one to each other. So, but as we are in our initial release only have the view transformation, you will only see this template you can use, and the operators to pull in will come at a later point in time. So to do so, I can either click directly here or click on the button to define the view transformation, and I will jump into an inner UI of the transformation editor, which is now describing our transformation logic. As I said, we initially bring in the graphical view transformation. Next will be the SQL and the SQL script view transformation, which would obviously bring you the respective editors. And the editor is actually a reuse of the graphical view builder today. So if I take my sales order items and want to join this with products, with the inner join here, it automatically happens, and I don't want to historically archive all attributes of products, so I will add a projection and only want to have the list price. So I basically will exclude everything and just re-enable the price. I do get an error here because if I use delta, I can use only one table as delta. It wouldn't make sense to load new sales order items and only new products. If the products hasn't changed, my join wouldn't find anything. So I have to, and this is what it tells me, I have to set the products to look at all active records. Now, if you remember back, we had those two types, so the products, so the active view and the delta captured view, basically with the underscore delta. This is where we're now switching. So we know switching is, okay, I want to join my changed records with the all active product table, so the one without deletion. Without deletion. to join those. And I have joined this, and obviously here it was set up so that it automatically found the join condition. I will now go into the projection and see where's the price. I will change the name because this is now my historic price, because it's the price that was valid at the point of loading. Once I've done this, I go back out. So now I have defined my view transformation, which is basically a view as well. And we'll write this into target table, and you see this UI is actually inherited from the data flow. I can either choose an existing table to put it in here, or I can choose a new table. Let's call this sales order items historic, so that I know this carries historic and delta capture is turned on, so it will also contain delta information. And I am going to save sales. Save and deploy this transformation flow. And as it's now deployed, I will also change the load type into initial and delta. If I do initial only, it will do what it says. It does all the initial, transfer it, but with the initial and delta, it will pick up all the delta changes every time. I should have done this before, so I can now deploy it again. Sorry for that. And now it's deployed. And I will also immediately run this. Good. So if we're looking in the data integration monitor, it shows up under flows. And we can see here basically we have the replication flow in Delta, and if we look into it, we see we have the multi-entities that it has been loaded and is waiting for the next load. Retrying means it's waiting for the next load, and you can see, hopefully for sales order items, we have loaded, actually I don't see how many resources it has loaded. So this has been transferred. And if I look at the replication flow, the transformation flow, that has also been processed. And here we see it has processed 139,000 records over into the table. And I'll just want to add one sales order item just to demonstrate how that will change now. Because remember, we had one leading Delta object in our transformation flow. I will choose the largest sales order ID so that I know which is the next one. Let's take this one and just duplicate it. Almost increment it by 1. And save it. You see it gets an I for insert. Oh, sorry, no. That's not the I for insert. The I for insert should be further back to the right. So here we see it has an I for insert because I have inserted one new line into this table. And if I go back into the transformation flows, and run it again, it should now pick up only the one record. And we see here, yes, it has processed only a single record, so only the changed records, the newly record. And the system will store, if you like, the delta pointers or watermark, as we call it, per target. So I can actually write multiple transformation flows reading out of the same leading delta table into different targets, and it would remember how far I have loaded the records from the source into each of those different targets so that they're correctly processed. It's not exactly the same as in BW, where you had a request handling. We do not have this, and we don't fully track all the changes in the sense that we have a full change history of before and after images, so that we really know how those records were before and after they were changed. Here we're only tracking change data capture. That means what was the operations, insert, update, delete, and when did it happen. So you do not know the version before. But other than that, basically you have the ability now to load delta more in an SQL style of way to process it. And not now, but in the hopefully near future of Wave 24, you will also be able to use delta-enabled tables as source for replication flows in order to write those information to outbound connections. Typically, those initially are going to be the object stores of the hyperscalers and HDLFS, as well as HANA Cloud. So this was a quick introduction in the new concept of transformation flows together with delta-enabled tables. And if you do not want to fill the data tables manually or through the data editing or through CSV uploads, you can use the replication flow to fill you these delta informations. With that, you have a new ELT capabilities, which we did not have before, especially with the delta capabilities and access to the full HANA capabilities and the full HANA compute power that is available to your tenant. Thank you very much.
Thank you, Hannes. And so let's move on to the next area with updates in the data modeling as well as in the marketplace area. And let me start with the first of these, which is that we support window functions now with Datasphere since release 2023-15. We introduced HANA window functions, which are now supported in views. So those window functions allow you calculations based on data in different groups, and we try to visualize that in the example which you find here on the right hand side. For example, you have different orders for different order dates, and of course they have different order values. And now if you would ask yourself the question, what is the highest value of an order on July 1st, on July 2nd, July 3rd, etc., etc. So you would basically need to group these by order date, so July 1st, and then find out which of these three has the highest value, in this case order number 2 with the value of 100. Right, and that's what you now can express in calculations in the views in Datasphere. And if you're looking for the documentation, because there are a lot of different functions for these window functions available, you find them behind the link in the documentation. So we also listed them here. And there are also a lot of aggregation functions here supported, like sum, min, max, average, standard deviations, and more. But without talking too much about the slide, let's directly look in the system. In the graphical view builder, for example, if you have a calculation node where you can create calculated columns, let's use that rank example here again. If we go into the details, we have exactly that rank over partition by order date and order value, example which we used on the slide, right? You also find those window functions here below in the function area, right? There's a separate group for it called window functions, and if you go there and click on the link, you find the expression, so the syntax and more details on how this works, an example also how to implement this, and this is there for all the different window functions. And this is not only available in graphical views, also want to point you here to the option for SQL views. We created an example also here. So similar to there, you completely code this in SQL. We use the very same example here with the sum over partition by order date and order ID, and with that running total. And yeah, as said, very, very similar in both and supported in both objects. So that's it from my side. And then let's look at more features in the data modeling area we introduced. Over to Jan.
With Wave 17, we are adding a new feature to the analytic model that we call constant selection. The business warehouse savvy colleagues might know it well from the past because there's a similar feature also there in business warehouse. And by constant selection, we mean that within a restricted measure, you can model to ignore a dimension that is actually currently in drill down and that is actually currently in filter. So why would that be useful? That is because within any given drill down, you really select only those applicable cells. So when you look at the drill down that we're having in the screenshot here, for example, we're drilling down by year and product category. And so when you want to express something that relates to an overarching figure, like an overarching total, an overarching category, an overarching year also, and so want to express something that is in a ratio to that, that is a difference to that, then you actually need to jump out of your current context. And this is what we are offering here now. And you model this as you see it here. So within the restricted measure, you can model it as you like. You base it on a source measure as per usual. You can or cannot have an expression. Here we chose to take the BI category or category 3 as a reference. And then there's a new section that is called constant selection, which you can choose to not have constant selection, which is obviously the default, have selected dimensions, or even all dimensions. So that is useful when your selection, the list of available dimensions might change over time with new modeling also. But the normal way of modeling is as you see on the screen. So here we choose to take the BI value as a reference figure. And so within the constant selection, we choose to have that product category, to ignore that, while at the same time in the expression actually use that. And so every value, whatever the current drill down is, always makes reference to the BI product category of that, whatever the drill down is, of that year, of that product, of that whatever, of that customer also. And this is how you can actually read the screenshot up there. So we're drilling down by year and product category. So the value comes down as per usual. And then when you focus on the rightmost column, that is exactly the measure that we're modeling here. And so that now jumps out of the current drill down. So we're drilling by year and product category. And so you end up with a drill only by year. You restrict by virtue of the expression in the restrict measure. You restrict on BI in that case, but you could totally also use the overall value across all categories or so. And then in this second column, percentage of BI value, you can sort of make comparisons. So here we chose to make a percentage ratio, but you can in the same way also make delta calculations also. So possibly let's jump to the system to fully grasp what we're doing here. So here we are at exactly the case that we just modeled, and now let's jump to the BI value. So the BI value is modeled exactly as we had it. So you have a product category, it's a restricted measure, and you're restricting by product category. While at the same time, we say that whatever the drill down is, when you are querying against this model, whatever that filter is that you are applying in that drill down, you want to consider all of those, but not the product category. You could choose any number of additional dimensions as well, not have any, obviously that's the default, or all dimensions. And so how does this now feel at query time? So at query time, we're saying, oops, yeah, that is the calculation. So when we're now drilling by product category, that becomes very clear that I'm drilling by product category. So here I'm selecting all the transactions based on the database, on the product category of database, on the data warehouse or so. And now, but the BI value is actually sort of not considering that drill down at this point. And so instead it says, ooh, there's really no drill happening in this column at all because that drill is not applicable within this cell here, but at the same time I'm applying a restriction, and this is why that value here, those 4234, are actually all the way down here. And so they can be used in subsequent calculations. I didn't show this earlier on, but you can imagine it's really a ratio of that number over that number. Obviously, this comes down here to 100%, while others, so like the 8 million here, are quite the double of that BI value. And so if instead we are now taking a fully different drill and say we're drilling by year, then this year number, again, that's my BI value in that year. Across all product, or so there's no product category drill down, but it's normal restricted measure. So that's BI value in 2020. And we can ascertain that by saying, oop, let's do that drill down. And so again, we're having that 3177 is exactly that number within the year of 2020, or if we take the drill down of 2021, it's this 1057. And by the same token, we could now sort of say, oh, let's filter on, say, one of these. So watch out to the database figures here, the 3328 or the 1047. So we could choose for the current drill down to apply a filter. And that filter, so we're filtering here by on the database number. And so those numbers, obviously, those filters are fully applicable, but they're not applicable for this measure here because we're applying constant selection. And so the drill down by 2022, but by year is fully applicable, but the drill down by product category and the filter by product category is not. And this is why this number is staying constant. And this is why it can be used for subsequent calculations. And this is very, very helpful because you're just ending up with a lot more expressive way of formulating measures. And this is why, it's super helpful, especially when taken together with standard measures, calculated measures, or even exception aggregation. So you're totally free to choose and mix and match and pile this up to any level and really not consider a current filter drill down at a certain point in time. And so enjoy. With Wave 17, we are introducing a small but for practitioners very important change, and that is that SQL views and SQL script views can now be saved even in case of errors. So why is this important? Very often SQL views and SQL script views are used for long coding parts, and it just may happen that errors are in them, and it would be just so helpful to be able to save that, go for lunch, grab a coffee, and continue afterwards. And so far we were rather strict in the way we handled such situations and said, there's no way we can save this. And now the system is a lot more graceful here and just allows a save anyway, even in case of errors. So let's see in the system how that looks like. So we're here in a system and say we create a new SQL view, and for the case, let's create a simple SQL statement. Really, any SQL statement will do. So do a select star on this. I format this, and now let's create an error. Very, a sure one. So we spelled this wrong, and now I hit save. I want to go to lunch. I want to continue my work later on, and so I save anyway. And so I say this is my error view, and so when I save this is now totally passable. And then later on, obviously the error is identified, and it's in design time error state, which is really correct, but I can totally come back to my work later on and continue from there. And that's certainly helpful for practitioners and good news.
Thank you, Jan. And let's look to the next topic here, which is the introduction of an internal marketplace possibility, right? So we already started a couple of years ago with the public data marketplace, everyone knows in the meantime. Then we introduced the private sharing option earlier this year, and now we complete this with the possibility to provide an internal marketplace. Internal marketplace means you have now the ability to really invite a whole tenant to the internal data marketplace context, and not just individuals in a private context, but this means really people on the full tenant can have access here to these data products. So it's part of several enhancements in the internal data marketplace. We already provided also live access here, and be aware only tenants that are in the same landscape can be chosen here to be part of such an internal marketplace. Let's have a look in the system. In your Datasphere tenant, you go to the context management of the data sharing cockpit, which is basically located here on the bottom of the menu. And there I already have a context for private data products. And now let's create one for an internal marketplace. And with the type, I can now select an internal marketplace and create that also with a validity date. I don't need that for the moment. And then if we go to the details, we find the context header, and in the context access details, I have the current tenant, but I could also add other tenants, as I said, in the same landscape, which could be part of this internal marketplace. And that's about it on the marketplace topic. There's one further topic I want to talk about, which brings us to the next area, catalog and administration topics. And that first topic is about the catalog, where we now also offer multi-pairing capability for multiple Datasphere systems. So up until now, we could only use the Datasphere system the catalog works on to be crawled with release 2023-16. We can now pair or unpair multiple Datasphere tenants and have those external tenants and those objects there accessed as part of the metadata catalog here. Be aware this also, similar to the marketplace topic, only works within the same data center, but also here let's have a quick look in the system how that looks like. So in your system, you go to the catalog monitoring area. That's where you find the different system connections. And here you can now create an additional connection and add additional Datasphere systems. So external Datasphere systems as well as analytics cloud systems, which were already there for quite some time. And you add it like your normal system, and then you can run the synchronization and everything as with the other systems as well. And then let's look at more topics here on the catalog side. Over to Gaëtien to give us more insights.
Hi everyone. Today we are going to show you two features, link between KPI terms and assets in the catalog, as well as extractions of column level attribute details for both SAP Datasphere and SAP Analytics Cloud assets available in our catalog. So first, let's go to our catalog and search for a specific term. So I would like to see the term business partner in our business glossaries. I select this term, and I would like to see its relationships. As you can see, this term already has relationships with assets as well as KPIs. We can define, change, and enrich the different relationships associated with that very particular term by clicking here on Manage Relationships. For example, let's link this term with accounting period, which is another term. So I can search, and I can select the accounting period term and add to related object, then save. As we can see now, our term business partner is linked with another term, accounting period. We can navigate to that term, look at its relationships, and we can see that there is a relationship. This relationship here is defined as indirect. That is to say, the relationship between these two terms was not defined here in the accounting period, but in the business partner term. If we want to change that relationship, we have to go back into the business partner, into the relationships, and then delete that relationship, for example. As we can see here, terms or KPIs, they can be related with other terms and KPIs, but also related with assets, and in particular, even measure within assets. So let's have a look at that. So this introduces the metadata extraction for the column level details or attribute level details for our SAP Datasphere as well as SAP Analytics Cloud assets that are available in the catalog. So for example, here we now have this detail tab, which has a list of measures and a list of attributes that are part of this object that we can have a look at the details. For both measures and attributes, here we will have several columns, business name, technical name, aggregation type, data type, for example. Or for the attributes, we can see that there is a key or there is a semantic type or whether it's visible or not in the story, for example. We can also see that it has a column that is named related objects. So for example, we can search for another value, and then we have all measures that has order in their name. So we can, for example, say that this BW order value, we would like to manage the relationship directly here. So we could, for example, link it with a KPI. So directly from here, we select the KPI and we add that link. You can use any of the columns that are selected as filters if you want to narrow the list down. And you can also customize the columns that you are going to see. We can also have a look at another asset we have in the catalog to give you another example of the details that you would be able to see. That's it for today. Thank you.
Thank you, Gaëtien. In the configuration area, we also added a minor but very useful description field to the IP allow list. This allows you here to add a text description to each of the IP or IP ranges which you have in your IP allow list. Looking at this in the system, you find this under the configuration IP allow lists section, where you now have a text description field which you can edit for existing ones, or once you add a new IP allow list entry, which you can simply add here in this description field. So with that, we finally have another section to look forward what we plan to deliver for the next few months. So over to Florian to give us the outlook on what we plan there.
Hi all, my name is Florian Neukirch and I will now walk you through the things we have planned for the next 2 quarters. Please be aware that all the innovations that I talk about are currently still in development and there might be changes in the delivery date. You can visit the Roadmap Explorer to see the exact delivery dates after the session today. In the Modeling and Use part of SAP Datasphere, you can await the following news. In Q1 2024, users will be able to derive values from other variables by the help of a lookup logic. And with that, we will have much increased dynamics in the use of variables and will enable new use cases like year-to-date or quarter-to-date. With the OData API, which is also planned for Q1, business users can use fact views with input parameters for the planning integration with SAP Analytics Cloud or for the consumption in third-party BI clients and applications. At the same time, the analytic model will be available for external consumption and is not limited to SAP Analytics Cloud anymore. Multilingual support refers to the capability to adapt the analytic dashboard to the language preference of the business user. And already for Q4, the folder support is planned. And with that, users can better organize the multitude of objects in the data builder by allowing the definition of nested folders and use one folder system throughout all builder areas and the repository inside of SAP Datasphere. The compatibility contract starting next year will make sure that selected views and analytic models can be marked as stable objects with a dedicated lifecycle information. The last innovation in this workstream will be the business layer time dimension generation, enabling business builder users to directly generate and use time dimension data in business builder modeling. The innovations for data integrations are all around the replication flow. And with the so-called premium outbound integration planned for Q4, the users have the possibility to load data into non-SAP target systems other than SAP Datasphere. For example, different hyperscaler storages, BigQuery and Kafka. And the replication flow will therefore support multiple file formats like Parquet, CSV, JSON, and of course JSON and Afro format for Kafka. And in addition, the tool will support the direct ingestion into BigQuery using the Append API. In Q1, SAP Datasphere will also provide the option to schedule the replication flow in task chains. For the operations section on this slide, you can see that we have 3 topics. The SAML API will add additional flexibility to the role management and simplify the administration. And the SCIM API is a public API that facilitates automation of Datasphere user and role management. Exactly. And we will also enable the command line interface, or short CLI, for several additional areas in the product. For example, we will have the discovery and CRUD operations on all data and business builder objects, except the connections and the replication flows. The CLI can be used for user and scoped roles operation and some additional data marketplace operations. At the same time, the so-called service account user access allows system-to-system connectivity with authentication through client credentials without the need to log in through IDP every 30 days. Coming now to data management. In Q4, Datasphere will support Boolean operators for data access controls. The elasticity concept for SAP Datasphere is planned for Q1 next year. And within the next 6 months, the data marketplace will also enable the connection to Catena X to exchange data with other Catena X members. At the end of the year, there will also be the option to find and replace records in the data maintenance part of the product to correct typos or missing values directly in Datasphere. And there will be the possibility to define the relevant subset of data products artifacts that is being shipped within a license via the data marketplace. And with that, we will reduce the amount of required data products that the data provider needs to maintain. For the BW Bridge, we are currently planning for several enhancements within the next quarters, like, for example, the handling and reuse of hierarchies, non-cumulative key figures, constant selection, and many more. Please relate to the external roadmap to keep being up to date here. And the last topic I want to talk about are the topics that are related to the catalog. This year we will add data products coming from the data marketplace to the catalog. The catalog will also support metadata harvesting for SAP BW for HANA Cloud. And the APIs we need to integrate with Collibra are currently planned to be delivered in Q2 2024. And prior to that, there are already be enhanced capabilities for the catalog admin user role. And that's all from my side. As mentioned, please observe the external roadmap explorer. And with that, have a nice day.
Thank you, Florian, and many thanks to all our speakers for preparing the content. This concludes the session for today. So thanks for being with us and see you next time. Back to you, Lacey.